While looking at all the various animals in the world, extinct and alive, sometimes you might see something familiar. When this happens, you might be seeing one of the most fascinating phenomena in all of nature: convergent evolution. A crocodile occupies a timeless ecological niche as a freshwater ambush predator. They don't need to stalk or chase down their prey, as their prey cannot avoid them unless they want to go without water. Their elongated snout helps them have further reach in the seconds they have to bite down on their target after their cover has been blown. Crocodilians fit this niche like a perfectly worn-in shoe, and have lived for hundreds of millions of years virtually unchanged. It would seem that crocodiles have stumbled upon the best body shape possible for what they do, otherwise it would have been improved on. Predating crocodiles, a monstrous amphibian known as Prionosuchus stalked the Permian 270 million years ago. This creature probably lived in a similar way to crocodiles, and as you can see, looks very much like one, despite not being closely related. This is because they have both converged on the optimum body plan for their environmental role. As they are sculpted by the environment, live in the same environment, doing the same thing, they have been sculpted in the same way. Early aquatic mammals like Cuchiacetus also started to look very crocodile-like back in their freshwater days, most likely due to living in the same way crocodiles do. So a mammal, an amphibian, and a reptile, separated by hundreds of millions of years, have evolved to look the same because they occupy the same ecological niche. Three-way convergent evolution is also beautifully depicted with sharks, dolphins, and later ichthyosaurs like Ophthalmosaurus. All three of these animals, despite being fish, mammals, and reptiles, have convergently evolved to look the same as each other. Sharks have looked very similar to how they look now for over 300 million years. Their fusiform body shape reduces drag in a high drag environment, and their dorsal fin gives them stability in the water. They have remained unchanged for so long because their body shape is optimum for the job they need to do. So these two originally terrestrial animals have developed most of the same features as sharks because this is the best body to have for living in the way they do. This example of convergence is very striking because the development of marine reptiles and mammals to these shark-shaped bodies also mirror one another. Nearly all ichthyosaurs vanished in the fossil record at the end of the Jurassic. Why their population dwindled is still a mystery, but they were taken over by mosasaurs in the Cretaceous. Mosasaurs were marine reptiles that evolved from a different terrestrial lineage that was related to monitor lizards, but they never reached the ichthyosaur levels of marine development to the point of looking like a fish. Their head was still separate from the body, and they still had large fins where their hind legs would have been. This seems to be exactly like how ichthyosaurs started out, and this can be seen from looking at much older species, like Symbospondylus. Symbospondylus lived in the Triassic and was much closer to the terrestrial common ancestor of ichthyosaurs, and they look very much like mosasaurs. This can also be seen in primitive whales like Dorodon, that also look similar to these other two creatures, with the head separate from the body and fins where the hind legs would have been. At the onset of the First World War, planes had been around for slightly over a decade, and no one really knew how to use them in warfare. The Allied and Axis power were creating designs for these new machines, and on numerous occasions converged on the same design. A very important invention that threw the British behind the technology race was synchronization gear. This invention would synchronize the gun with the propeller, stopping the machine gun from firing when a propeller blade was in the path of a bullet. This meant that the gun could be mounted on the pilot's line of sight, greatly increasing accuracy. Just over a year after the Germans had cracked how to do this, the British also worked it out with almost exactly the same method. Although the engineers of these two countries had nothing to do with each other as they were at war, they converged on the same blueprint as this was the optimum design given the technology available to them. Convergent evolution is no different. If there is an optimum way to do something, many creatures will evolve to do it. When an animal or plant converges on the same morphological trait, it is known as an analogous trait. An example of this would be an ant's leg compared with a cat's leg, or a bat's wing compared with an insect's wing. All of these structures are used for the same purpose despite being made differently. The slightly uneven inverse to analogous traits are homologous traits, where the comparisons are made from anatomy rather than function. An example of this would be a whale's fin compared with a cat's leg, or a bat's wing compared with a human hand. These structures serve different functions, but as the animals are more closely related, are made out of similar materials. Analogous traits arise from animals surviving in the same ecological niches, but don't have close relation. Homologous traits are when animals have close enough relation that their anatomy is similar, but have evolved in sufficiently different environments. A penguin's fin is analogous to a dolphin's fin because they both live in aquatic environments and hunt fish. and a penguin's fin and an eagle's wing are homologous because they are both birds and their common ancestor would have had wings. It is also worth mentioning that animal traits can be both analogous and homologous, a good example being marsupials. The common ancestor of marsupials and placental mammals probably lived about 165 million years ago, at the end of the Jurassic, when all mammals looked like rodents. All the marsupials in Australia have evolved separately into larger animals and have numerous examples of convergence with placental mammals. Thylacines are very similar to canines, and their skeletons are virtually indistinguishable from one another. Sugar gliders are marsupials and are able to glide down from the trees just like flying squirrels. And there is even a marsupial mole that lives exactly the same way moles do. All of these animals have converged on the same body plan because of evolving in the same environment, but are closely related enough to share anatomical resemblance as well. If 90% of animals and plants died out tomorrow and had to evolve back into the ecological niches again, the world may be more familiar than you think. Arguing that convergence is a dominant force in evolution, and given that the same environmental and physical constraints will still be at work, all animals will inevitably move towards the optimum body plan. So it may take a long time, and the new animal may not be anatomically similar or homologous to the ones today, but all the ecological niches will be filled. Mudskippers developing to live on land, at least some amount of the time, is very similar to Tiktaalik, the fish that is the common ancestor of all terrestrial invertebrates. So something usually seen as a massive transition for life, or at least terrestrial life, is happening for a second time. Or rather may happen if there was no competition on the land. But what if humans went extinct? Would another animal convergently evolve that looks like us? Or maybe they almost did once. About 2.5 million years ago, independently from monkeys, lemurs evolved their own version of an ape. Archaeondrus was a lemur that converged on the ape body plan. If these creatures didn't go extinct 2,500 years ago, and were able to carry on evolving, who knows? Thank you for listening. If you like the video, please subscribe, and if you really like the video, please consider supporting me on Patreon.